Our next speaker is Martin Ørsted. He's a group manager for engineering at Microsoft Office. I have known Martin for a year or two. He's on the LRC advisory board. There have been meetings. Microsoft has over the years always been very, very supportive of the work of the LRC, and we've collaborated on many different things in the past. And what really got my attention in relation to Martin is that he's one of those people who's actually, who's translated something. So there's lots of people in localization, who write tools and manage and design workflows, and they probably have, some of them have probably never even spoken to a translator, never mind, translated anything themselves. So Martin is somebody that really knows, I think, what he's talking about, engineers talking is kind of a contradiction of terms sometimes. So Martin has a background in languages and translation, and at the same time he has great knowledge and many, many years of experience in localization. So I'm really looking forward to his presentation. This is subject localization validation across languages, and I would like you to welcome Martin.
I actually thought I'd start by saying that today the one area I wouldn't care about was the actual translation itself. Because the thing is this, one of the problems with localizing software is that the actual translation itself is not necessarily the biggest cost. When you come to it all, when you come to the management, the bug fixing, the testing, any kind of bulletproofing you may do, it may turn out that the actual translation cost itself is maybe a quarter of the overall cost that you encourage to get your product out on the market. So what I want to talk about today is some of the other things that you can do. We'll also talk a little bit about driving down the actual translation cost, but it's the other things. And so that's kind of the proposed content. If you look at the upstream effort, and again that's not what I want to talk about either, but I just want to mention it in the sense that if you can get it fixed at development time, that's of course the best place to get things fixed. But in realization of the fact that very often development is on a fixed timeline, there are trade-offs that are made. It doesn't always, you don't get what you want, but some of the things you can ask for is the use of newer programming languages, and get your developers to use pseudo localization rather than just checking what they do on US. Why not check it on pseudo? Educating the developers. I once sat down with a group of developers and told them that if they didn't qualify the placeholder, we had no clue what was actually going to be dropped into it at runtime, and we would have a hard time localizing the string. That was a revelation for the developers. They didn't know that. So educating, use of control language. I mean, if you can control the input into the localization engine, then of course you can also better control the output, and you can stabilize your process a bit. And the source reuse systems. I mean, I don't know in Microsoft, I don't know how many strings we have that basically say the same, that Microsoft Word could not find the file %s or something like that. If they could, for crying out loud, just say it in one way and stick to that, it would be easier for us. So some of those things you can do, but the deadlines, the trade-offs, development languages aren't perfect. Some issues you just don't want to bulletproof and it doesn't make sense. So it's never going to be a perfect story. And this is where this particular story now picks up, because I'm saying I do my best in this space, but it's not going to be perfect, so what else is there to do? So the downstream bulletproofing, then you try and go in and say, okay, how can I stabilize the environment? And how can I remove the error sources still so that I basically guard against them from the localizer? So rather than waste a lot of time trying to find the errors after they have committed system that's more catches them real time, or systematically removes them. And the thing about it is that the more languages you add on, the more investment you can afford to make up front before you start the localization. So I'm in office localization, and the main applications are now localized to more than 100 languages. So that means the reality for me is that, well, I can actually afford to invest a fair bit in trying to fix things up front, because any mistake that can otherwise be made can be made 100 different times, and that multiplier is fairly punitive. So there are things I can do there, and that you can do when you have your languages. So let's start with the single resource issue. So this is where I take my old localizer hat on, but some things like that you can see are over localizations. The string should not have been translated. In an ideal world, the string should not have been exposed to localization. Buffer limitations, you can only have a certain amount of characters. If you have more characters than that, you get a buffer overrun, you get a crash in your product. Illegal characters, if the string becomes part of the file name, you can have backslash and it can have certain characters, but there are other characters that are not allowed. Backward compatibility, you change the string and suddenly you can't open the last version of your product for some reasons or others. Placeholders, they sometimes just over-localize. String decoration. I've given a few examples here. The last one I remember with still, because that cost me a full weekend to figure that one out. So it's a real one I had. The 5% less was last open on %D, and that had been in Swedish translated to the equivalent of on %D, the 5% less was last open. And the problem there is that % less is expecting a pointer to a string resource. And what it gets instead is an integer, a long integer, which has the same length. It just goes, takes that integer, says that's an address, jumps there, and if it's within your allocated memory space, you get crap. If it's outside of your allocated memory space, you get a general protection fault, and the system closes down. So those are some of the things you can see. So in Microsoft, and this is old hat, so we are traveling through time. This is kind of, we introduced this maybe 10 years ago, and we've developed it since. We have what we call the logware rule, the localization verification rule. I'll give you one simple example. Let's say you have a string in Excel current accounts, you get a crash bug, and you realize, well, if anybody localizes this particular string with more than 30 characters, it causes a buffer overrun. That is the 30 character limitation. So you create a rule called max length equals 30, and you put a system in place. That's not as easy as said, of course, but you can do it. You put a system in place that automatically runs that rule against all of your languages when they've been localized, and as soon as anybody else breaks that rule, you catch it. I'll come back to this a little bit later, but the inference of that is you go to the testers and say to them, you will only ever need to find the same issue once. And we will guarantee you from engineering that we'll fix it across all languages without you having to do anything else. Maybe something else can break the same string, we don't cover that, but once we know it, we'll make sure we catch it for all languages. We tell them testing that, and we tell them, and by the way, now go and change your testing approach so you don't hit the same thing with a hammer 30 times or 100 times. So the approach is actually that philosophically speaking, identify the issue. You can do that by you're finding a bug. You can identify it through looking at the strings. You can identify it through code review. We use all of those approaches. Whenever you identify that there is a kind of a limitation to the string, you create a rule that systematically prevents that issue from occurring, and then you put a system in place that runs it against all your languages and you're done. It'll never occur again. That's the way you do that one. It's fine, one fix everywhere, so with 100 languages, it works out pretty cool. It enables reduced test. There's no need for test regression against other languages. It's just a waste of time. And I've noticed with our test group otherwise, they love regressing bugs. But we can tell them, don't even waste your time on that, we'll fix it. The minus is that you need to have good few languages going before this becomes something that you're interested in. It's a fairly manual effort. I mean, you either have to find it through a bug, you have to look at the string and realize it, or you have to do code review. So it costs you resources. And there's also a management overhead, because if you have too many of these logware rules, whenever the translations change, you have to go and look through these rules again and see if they need to be updated. And finally, one caveat that you need to be aware of is that logware is often kind of a workaround. It's not a fix. Logware is documenting a known limitation as opposed to fixing it. So you need to make sure that your engineers go back and say, think critically about it and say, is this an acceptable limitation? And will we just document that limitation and that's it? Or will we go back to the developers and kick them and say, that's not acceptable, we can't do proper translations for our languages there. So those are kind of the pitfalls. But within that framework, if you manage it proper, it gives great return on investment. But this is not what we prefer. It costs us too much time. So what can we do instead? Well, if you can look if you can identify generic classes of issues, if you can, through looking for patterns, come up with ways of saying, well, let's say with the placeholder, for example, if we know that person 1, person 2, person S, person D, if we know that they are always placeholders, let's jack all those logware rules out and create a generic rule that we just apply to all strings wherever we find them. And if we see person S, or person D, person 1, person 2, treat it as a placeholder. The advantage of that is that as soon as a new string gets added to US with a placeholder, it's automatically covered. We don't need to do anything. As soon as the string with placeholders in gets changed, it's automatically covered. So it drives down the management. Now, the thing is this, there are lots of things that you can't look for patterns for. So when you can do this, that's the way we now prefer to go. But very often, that's not possible, and then you default back when you need to your individual rule approach. So the positive thing is that there's less management overhead. We talked about them. We pretty much covered that one. In between there, we kind of have a hybrid almost. So we've developed this system over the years, so we can now run scripts, and those scripts cover a group of resources. And either through, you still have to kind of annotate each resource somehow, but then it'll cover that group in various different ways. I, for example, used it with Word, where all my style names in Word have to be different. You can't have two styles all the same, but obviously the system can't handle that. So that's kind of an intermediate between that. But philosophically, you have the one the per resource approach, and you have the generic approach where I try to do it across resources. And the latter one is nicer. But you only want to do that for functional issues. Now, we are also, of course, responsible for that the legal stuff is okay, that the geopolitical stuff is okay, and certain styles of linguistic issues you may also be able to capture. I think last time at LRC there was one person that demonstrated a tool that pretty much used SQL rules to catch certain localization mistakes, if you like. So we do that as well. We run simple queries, US contains 2007 localized version. The localizer overlooked that string had been updated with the copyright year. Or Microsoft, the US contains Microsoft localized version. Most of the time that's benign. We don't care about that most of the time. But once in a while it's sitting in a copyright string and it would be quite nice to have it there. Xdocs until very late stage. And then that was a code name we used for it during the whole development cycle of localization. And then in the last end, they agreed, okay, let's call this one InfoPass. And when we started doing SQL queries for Xdocs, we actually found places where somebody missed to change it, forgotten to change it. Some of these things you can also address through, for example, tokenization. So you could take the product names out, you could run a little process before you send it out for localization, and tokenize your product names, the things you care about. So you just localize them in one place, and that becomes easier for you then to handle things like Xdocs. So you just run them once or twice. They'll give you a lot of false positives, but you don't care too much about it because this is not functional quality, it's just to make sure that certain mistakes can be caught. And when you do it that way, it's worthwhile doing it. In the old days, we would have used logware for some of those things, and that was just plain stupid. Because you don't care enough about it, and you get false positives, you don't want to see those. Again, it gets smarter with the added language I mentioned, so let's start talking about that. So we've actually just traveled through time in the sense that logware started for us maybe 10 years ago. The log rule probably started 3 years ago. And this is kind of where we are now in a philosophical way in terms of, well, what are the next steps, what are the things we can do now? So when you add a lot of languages, you can start learning things when you look across languages. And the thing is this, that normally when you look at the way what it costs us to localize and release a language. One language costs X, 2 languages cost 2X, and 10 languages cost 10X. We don't want that. We want to change that dynamic. The translation, we pretty much accept that will follow that rule. But there's no need for the testing and the engineering to follow those rules. You should be able to break that pattern. So how do you do that? And so that's what this is about. You can start looking for patterns. We did that in one of our projects where we localized 60 languages in the first lib effort. So we said if 9 out of 10 languages start with \n, should the 10th language also do that? 9 out of 10 protects Microsoft, should number 10 also? If 9 out of 10 languages localize 2 resources the same, should number 10 also? The word open in English, typically in our products, it appears in 2 different words. The infinitive version, to open, that's your title. Lots of times it occurs like that. Then there's the imperative version, open the file, open the document, open whatever. It gets translated different for most languages, so therefore you just let them stay there. The amount of times they occur, you just have to let them stay there because you don't know, do they mean the same or is it different meanings that's there. But if you start looking across languages, and if you realize that 9 out of 10 languages localize these 5 sets of open in one way, and these 3 sets of open in another way, then you can be pretty damn sure that you've identified the 2 users. Then you can collapse them, just localize them once, and if you then also look for decoration, basically strings that always starts with something. If you remove that systematically as well, just doing those 2 things can actually drive your localization costs down with more than 10%. I'd actually say you could probably drive down locations with more than 20%. That was the learning we got when we tried that for our language interface packs. The nice thing about this thing is that you're basically using the intelligence that has been added by all the people that have been localizing for you. By starting to look across the different languages, you use that intelligence to sort of realize, to get learnings about your product that you otherwise would not have been able to do. Running a SQL query between US and one language can give you something, but if you can start looking for patterns against 10 languages, you can identify a lot of issues you wouldn't otherwise have been able to identify. So we have created what's that called? An intelligence system that kind of does these things now. And At the moment, we haven't really fully added the language dimension yet, but then again, we're not in full production yet, so it's in the pipeline. When you have a lot of languages as well, there are things you can do. So some of these things I will add for a lot of people, I'm sure. Dynamic auto layout. It just makes sense. It even makes sense at some stage if your developers don't give you dynamic auto layout. It actually makes sense for you to change the dialogues to dynamic auto layout as part of your journey. We've done that. We introduced the concept hotkey fixes. So we are, for the next version, we are localizing. We are telling people not to worry about the assignment of hotkeys at all. That usually costs us a fair amount of bucks and a fair amount of headache. But we put a system in place where we dynamically are, not dynamically, but we have a process that can assign the hotkeys to all our dialogues and menus. And it understands the mappings and the dependencies. You can group on code pages. If you look at the ANSI code pages, you typically, for the European ones, have 5 ANSI code pages. Maybe you could convince your testers that if we do really good tests once on each ANSI code page, maybe for the other languages within the same code page, we can start cutting down a bit. Controlled English, variable, transliteration, empty. So we're doing, for example, languages like Portuguese, Brazilian, and Iberian Portuguese. If there was a decent MT engine out there between those two that did not have to be handheld all the time, it would be an obvious one to try. So the closed language pairs, for example, get into play as well. This one is really important. So I've spent a little bit of time on that one, because I'm doing pretty good on time. Test case versus test design specifications, the instruction of randomness. So in the old days, we tended to hit our products dramatically with a hammer for each language. We just went through it like monkeys from A to Z for each language. And we did that because we do, of course, need to make sure that this is perfect. People pay money for it. It has to be just good. But a funny thing happened last time. For example, we had a bug where this was comparing two project databases. We tested it for a lot of languages and it worked perfect. But then one day a lazy tester broke the rule. So rather than following the test case specifically and test this project file out and this project file out and compare them, this tester had 2 files lying on the computer and used them instead. And sure enough, the product crashed. And the learning there is that the introduction of randomness is a fantastically valuable source for further learnings about your product. So that's what test design specifications is about, which is where we're moving to. So don't tell your people to, open Word, go to mail merge, choose these lines, do this, do this, do this, do this, do this. Instead, tell them, say, listen, mail merge, this is what's new in mail merge, these are the new features, these are the new things it supports, and go test it. And by the way, that tester might be testing it for certain languages, so they learn about it. But every time they go through and there's a few people, they might do things slightly different. And remember, we only have to see the issue once, and we'll make sure it never occurs again. So we're not interested in people following exactly the same path through the product. The small changes can actually be the gold that really uncovers the nasty bugs that might otherwise only have been caught after release. So getting that randomness in there for us makes a difference. Now, I don't remember if I more slides actually. Yeah, so if I look at it in terms of the value I get, the single resource rules, I love them actually. And whenever you do find a bug, that's the way to go because it's gone. Find once, fix everywhere. But if I do my generic rules and SQL queries, it costs me much less work and it spans a lot more. So I get a lot more out of it. It's more valuable for me. But if I add the language dimension, and then start looking for patterns across languages, then I get an even better, because this one is where I need to do the least, but where potentially I can find the most. So, so what does that mean in practical terms? But what it does mean is that you can, with certain languages, for example, you can seriously start driving your test costs down. And that's one of our biggest costs. And you can do that because the approach you take pretty much ensures systems are systematically, or errors are systematically ruled out. The other one, my peer, the test group manager in the office group, we talk about bulletproofing the localization process. So what we are saying is, well, if you have a good US product without bugs, if you can create a totally bulletproof localization process, you should spend very little time testing the actual end product. So you test the process rather and figure out where the process introduces issues, and you spend less and less time on your languages. And because the languages, that's where your real test costs come in, because they go up as the languages go up, you start driving your costs down. You also drive your engineering costs down. And by using this approach, these things they can find, especially the single resource rule and some of the generic rules, they can find issues fairly early. And you use that together with pseudolog. I think I have something on it. Yeah, I didn't mention that. One of the things we've done is we use pseudolog heavily. But we do pseudolog on the code page. But we've taught our pseudolog to understand our logware rules. So when we pseudolocalize a product, we pseudolocalize it within those rules, within the log rules and within the logware rules. What that means for us is that the pseudolocalized product, we don't waste time finding issues we already know about. The only issues we'll find with using pseudolog are new issues. And we then vary it, so we test pseudolog on different code pages, different regional settings. And by doing that, we move the finding of the serious bugs upstream, finding early. That again can allow you to delay your translation maybe, and that again is a cost saver. So coming down to it, I guess, what I'm trying to describe here is basically that this approach, when you have a lot of languages that you need to localize, and there's a fairly high cost associated with it, where you start investing more money up front, and by doing that, you can bring your overall cost down, you can bring your overall quality up, and there's a fair headache with getting the system in place properly, but if the cost is big enough, it becomes worthwhile. That's yeah, I pretty much said all of that. It's really only, besides the things I mentioned, it's really only your imagination that decides where to stop. So when we did the first lit language, we had to resize our dialogues. We had to resize 850 dialogues roughly per language. So we came up with a little mathematical algorithm where we looked at the dialogues we already had in the first 30 languages. And then we calculated the pixel lengths of each item in each dialogue. And then we saw every time we had a new language, we went out and saw if we could find a dialogue that had already been resized and recycle that rather than resize it ourselves. And it was probably one of those solutions that took us a couple of months to do and saved us a couple of weeks, but it was fun. And we engineers who do things like that. For Nynorsk, it meant that rather than resizing 808 dialogues, we had to resize 25 dialogues. So that was pretty cool. And again, it's just an example of it's really only the imagination that stops you. There are so many things you can do when you add the language dimension and start thinking about things in a different way. And that's it. That's all I have to say.
Thank you very much, Martin, for a very interesting presentation. To give a twist to what I said in the introduction, and you were talking about, we are talking a lot about translation, and a lot of people find it difficult to understand what is the difference between translation and localization. And I think this was a brilliant example of what the example of your talk and the content of it, find out what the differences are between localization and translation. But also, I always thought that translation was the biggest cost of localization. So I learned something. Are there any questions? We have a little bit of time before we go to our coffee break. Lots of questions, actually. Some of the things that you said to make a product bulletproof is kind of it's not so much working with the developers and doing it at the development stage, but just taking what you get and trying to work with that and analyze it and then maybe identify issues in one language and then carry that over to other languages and also learn from project and version to project version. Two questions there. One is, do you think that some of this, you have kind of answered it in your talk already, do you think it's some of the errors can be found by developing automated tools? And I think you said yes. And the second question is, you built up some localization knowledge, about products and about languages and about issues that come up. What is the best way to store that knowledge, you think? And to reuse it and maintain it?
So the first one is that there's a systematic way to kind of avoid a lot of issues. Yes, of course. We're getting better and better at that. So some of the things that have been introduced in the industry lately are code analyzers. They're used to catch security issues, but they're also used to run in something called goldmine, I believe, that we run against some of our products, and we use that to find different kinds of localization issues. And when we find them, we can go directly back to the developers and get them to fix it. But there is just a point where it just doesn't make sense any longer, and there are certain things where there are good big group of localization bugs that I actually think I wouldn't really blame on the localizers. I would blame it on the systems we put in place almost. If you localize certain XML code or things that go into an XML page, there are certain rules you just need to abide by, and if you don't do that, things go bad. So if your log tools are not good enough, then that's where you should unfortunately blame a lot with the developers. So the second question is it possible to build up kind of what are the biggest issues and build up a knowledge base with that? Well, so the problem is, I'm in an engineering organization. We're notoriously bad at documenting things. But there is, of course, various things you can do. I actually would agree with the speaker before me that we used to kid ourselves into believing that the localization business was fairly unique business, and we ran all kind of unique tools and processes. But save for the actual act of localizing, the rest of it is plain vanilla. I mean, it's a simple supply chain design problem. And if you approach it from that, and if you use the best practices within the industry, you'll get a long way. You'll design better systems. So that's the first way that's the way we're thinking about it now. The second thing is sort of proper data mining. So look at the sources you have. You have your source of bugs. That's a very important source to learn about. And what are the things that are sort of historically going wrong? And the other one is again, if you put a proper metric system in place so you can capture where you're spending your time, where you're spending your cost, and you do proper root cause analysis, then I think we get there as well. We learn a lot of things, but building up that repository and sharing that knowledge, I find pretty difficult, and it's a constant problem we have. Every time we start localization, we pretty much have to try and share this knowledge with the vendors we work with, and it is fairly difficult for us. And so there's no easy answer, I guess, not to me. for example, with images, I mean, the biggest no-no in the industry is images with text on it. Split it up, have an image, programmatically throw the text on top of it, or make it as whatever JPEG file with various layers where only one layer holds the text. Icons, you know, we prefer to keep them very simple, so try to make it an icon that doesn't need localization. If you can keep it generic, please do that. Other than that, what we tend to do is, to the extent needed, we tend to just specialize that with one single vendor. We can't do it ourselves, we don't have proper knowledge. But it is it's a different skill set. I have localized bitmaps myself, and it's a mess. But it's so far removed these days, it's not a big deal for us. I think they in general do the right thing, so it's not that big a problem.
Well, if there are no further questions, then we can take our scheduled coffee break, which is great. So thank you very much again, Martin. Lots of questions actually. Some of the things that you said to make bulletproof is kind of it's not so much working with the developers and doing it at the development stage, but just taking what you get and try to work with that and analyze it and then maybe identify issues in one language and then carry that over to other languages and also learn from project and version to project version. Two questions there. Well, one is, do you think that some of this, I kind of asked it when you talked about it, do you think it's some of the errors can be found by developing automated tools? And I think you said yes. And the second question is, you built up some localization knowledge, about products and about languages and about issues that come up. What is the best way to store that knowledge, you think? And to reuse it and maintain it?
So the first one is that there's a systematic way to kind of avoid a lot of issues. Yes, of course. We're getting better and better at that. So some of the things that have been introduced in the industry lately are code analyzers. They're used to catch security issues, but they're also used to run in something called goldmine, I believe, that we run against some of our products, and we use that to find different kinds of localization issues. And when we find them, we can go directly back to the developers and get them to fix it. But there is just a point where it just doesn't make sense any longer, and there are certain things where there are good big move of localization bugs that I actually think I wouldn't really blame on the localizers. I would blame it on the systems we put in place almost. If you localize certain XML code or things that go into an XML page, there are certain rules you just need to abide by, and if you don't do that, things go bad. So if your log tools are not good enough, then that's where you should, of course, you blame a lot with the developers. So the second question is it possible to build up kind of what are the biggest issues and build up a knowledge base of that? Well, so the problem is, I'm in an engineering organization. We're notoriously bad at documenting things. But there is, of course, various things you can do. I actually would agree with the speaker before me that we used to kill ourselves into believing that the localization business was fairly unique business, and we ran all kind of unique tools and processes. But save for the actual act of localizing, the rest of it is plain vanilla. I mean, it's a simple supply chain design problem. And if you approach it from that, and if you use the best practices within the industry, you'll get a long way. You'll design better systems. And so that's the first way that's the way we're thinking about it now. The second thing is sort of proper data mining. So look at the sources you have. building up that repository and sharing that knowledge, I find pretty difficult, and it's a constant problem we have. Every time we start localization, we pretty much have to try and share this knowledge with the vendors we work with, and it is fairly difficult for us. And so there's no easy answer, I guess. Not to me at all.
Melvin from Localisation. Most of the examples you've given is mainly looking at strings. So I'm just wondering, do you face any issues in terms of like localization for images, icons, and
Oh,
all
yeah,
the problems that you face?
Yes. So for example, with images, I mean, the biggest no-no in the industry is images with text on. Split it up, have an image, programmatically throw the text on top of it, or make it as whatever JPEG file with various layers where only one layer holds the text. Icons, you know, we prefer to keep them very simple, so try to make it an icon that doesn't need localization. If you can keep it generic, please do that. Other than that, what we tend to do is, to the extent needed, we tend to just specialize that with one single vendor. We can't do it ourselves, we don't have proper knowledge. But it is it's a different skill set. I have localized bitmaps myself, and it's a mess. But it's so far removed these days, it's not a big deal for us. I think they in general do